So welcome to Python's Data All-Star Mastering the Core Types. We are starting with this Python's Data Playground. Here you'll meet the stars of the show, the core data types that make Python so powerful and fun to use. They're like building blocks that let you create all kinds of amazing things, from shopping lists to video games to AI-powered chatbots. Now let's dive in and meet the game. First off, numbers. And these data types start with integers, or int, whole numbers like 42 minus 100 or 0. This is perfect for counting pizza slices or taking your wins in a video game. Next up is floating point numbers, or float. Numbers with decimals like 3.14 or 1.5. You can use them for measurements, percentages, or calculating the odds of winning the lottery. And complex numbers, or complex. Numbers with real and imaginary parts like 2 plus 3j. They are essential for advanced math and engineering, but don't worry if they sound a bit out there for now. The next data type is strings. Strings, or str, are text enclosed in quotes, like "Hello world" or "What's your favorite ice cream flavor?" Use them to store names, messages, song lyrics, or even entire novels. Next up is lists, the ultimate organizers. Lists, or list, ordered collections of items like 1, apple, 3.14. Think of them as flexible boxes that can hold any kind of data. Use them to make shopping lists, store your favorite songs, or record your workout progress. The next data type is tuples, the unchangeable squad. Tuples, or tuple, similar to lists, but once created, their contents can't be changed. Like a locked box with valuable items inside. Use them to store coordinates representing dates or keeping track of settings that shouldn't be modified. Another data type is dictionaries, the key masters. Dictionaries, or DICT, unordered collections of key value pairs, like name Alice, age 30. Think of them as magical address books where you can instantly find information based on a key. Use them to store contact information or details, create word translations, or build a virtual library. Next up is booleans, the decision makers. Booleans, or bool, represent truth value, either true or false. Use them to make choices in your code, like deciding whether to send a message or skip a song. And finally, none. And now let's switch to some hands-on exercises. And in this first script example, we'll start with integers for counting and tracking. As you can see, the first example is a variable pizza slices equals 8. This is a whole number of slices. And this is integer. We'll be talking about variables a bit later, but for now, we just take a look at data types examples. So if we run this example, pizza slices 8, let me select it and press Shift-Alt-E, and it will run this selected part of code. By the way, I'm using PyCharm IDE, and It's free edition, you can download it and follow along. Just type in PyCharm in Google search engine and find the official link, download it, install it, and then start the new project. Create a new Python file and you are ready to go. So back to our examples. Now if I type print pizza slices and again press Shift-Alt-E, it will print 8. So this 8 is an integer data type. Another example is high score equals 1200. If I select it, by the way, I can just press the mouse here and press Shift-Alt-E, and this line is executed. Now I can type print pizza slices and output the result. Sorry, not pizza slices, but high score. As you can see, it outputs 1200. Next up is floating point numbers for measurements and calculations. For example, we could add such a variable pizza diameter equals 33.5. We can run it and print it. And it prints out 36.5. Lottery odds printed, and as you can see, it's a tiny chance of winning the lottery. Next up, we've got this complex number for advanced math. For example, this example from quantum physics. Quantum state equals 2 plus 3j. Another type of data is string. As you can see, we've got this string hello world, it's Python time. And we can print it out by typing Shift-Alt-E again. You can see the output is there. And now you can see how we can use it. For example, we can use it with input method. And we can ask a user to put in the value, for example, for their favorite ice cream flavor. As you can see, we are using this variable favorite flavor, and it equals the input that user adds to this variable. Let's run this code. I'll press Shift-Alt-E again. And now I can add some information about ice cream I prefer, for example, cherry. And if I print the contents of favorite flavor variable, it will output the following text: awesome, I love cherry too. Next up is lists. You can get organized with lists, for example, by creating shopping list with mixed items like shopping list equals bananas, milk, eggs, and number for quantity. Let's print it out. We'll be talking about the syntax of creating all these data types a bit later, but for now these are just examples. Another list you could create is the list of your favorite songs playlist. Like Bohemian Rhapsody, Imagine, Dancing Queen, and when we can print it out again. I type in print playlist. We can also add items to the playlist with the append method. We'll be talking about much more about these methods, but for now, just know that we can add items to the lists. Again, by using input like new song equals input. Again, we can add this to our list by printing this new song like us and them. Now this playlist append method is applied with the new song information, and we can print it out. As you can see, we've got updated playlist, Bohemian Rhapsody, Imagine, Dancing Queen, and it seems like I forgot to use quotes. Remember, we use screens with quotes. So let's run this code again. I'll run this new song. I'll type in double quotes, us and them. By the way, it's Pink Floyd. I'll append this method and print it out. And as you can see, this us and them item is placed in this list. The next data type is tuples. Tuples cannot be changed, opposite to lists. And we can use them for coordinates, for a treasure map, for example. And as you can see, the syntax is different from lists. So let's run it and print it and run it again. The coordinates are ready. Don't tell anyone these coordinates. Birthday dates, you also use the tuples here, like birthday equals this date, and we can print it again. And now let's take a look at how we can change this tuple. We'll try to change the tuple. So I'll run this code treasure location and try to add an item to the tuple. As you can see, we've got an error. Tuple object does not support item assignment. The next data type is dictionary. You can use dictionaries for contact, book with names and phone numbers, like this one, contact book equals Alice, her phone number, Bob, his phone number. Let's print it. I'll type print contact book and run the code. We can use dictionaries for translation dictionaries also, for sure, like hello, hola, goodbye, adios, and so on. Let's run this line. And now we can look up a translation in this dictionary. For example, we'll add this variable word to translate with input method again, enter an English word to translate. So let's run it. And let's add the word we want to translate. For example, hello. Sorry, again, double quotes. And let's print the results. Print word could translate. And now run this piece of code. If word to translate in translations, print the translation of the word. If it's not, print word not found in the dictionary. As you can see, it printed out word not found in the dictionary. Let's try another word. For example, goodbye. I'll run this word to translate. Add the word goodbye and run the code. And as you can see, it's translated the word with adios or adios. Next up is Boolean. Boolean for making decisions. For example, checking if it's raining. Is raining true? Or decision to go or not to go for a walk. We can run the following code. If it's raining, we are staying inside. And if it's not raining, we're going for a walk. As we added this variable before, is raining true? The output is staying inside to avoid the rain. If we change it to false, and run the code again, it outputted another decision, going for a walk in the sunshine, because this is raining is false. And finally, this mysterious stranger none. You can use it for a placeholder for a value that's not yet known. For example, Mr. Gift equals none. Let's run this code and run another code. If Mr. Gift is none, the gift is still a mystery. Else print the gift has been revealed. So I'll run this code, and we have this output, the gift is still a mystery, because of this variable, Mr. Gift equals none. If we change it to car, for example, and run the code again, as you can see, the gift has been revealed, because now we know the value of this variable, Mr. Gift. It's a car.